So our HP Network Management Center is an integrated solution which is designed to support a service-driven operation. At the pinnacle of this solution is the BSM dashboard, which provides service-oriented event consolidation as well as cross-domain management. Some of the core products of the Network Management Center is comprised covering across the FCAP model, which also supports that ITIL version 3 best practices. Furthermore, the core of the solution is integrated to ensure maximum operator efficiency and effectiveness. Lastly, the core products can be extended through these add-on modules called smart plugins for managing advanced services such as IP telephony, MPLS, and as well as IP multicast. The foundation of the Network Management Center is built upon the integration with UCNDB for shared service context, as well as standardized integrations via web services, as well as extensive out-of-the-box integration catalogs for ITSM, as well as BSM and A&M. The top three products, which include network automation, NNMI for fault and availability, and performance monitoring. These are the core NMC products. The next row below contains and adds functionality and value to a more integrated approach to network management. I'd also like to point out that the Network Management Center products can also be used in isolation or as well as part of an integration approach with other HP, BTO, or competitive IT software solutions. HP Automation Network Management, or A&M, enables customers to reduce costs as well as increase agility by unifying automated across all network operations. Unlike point product approaches that HP offers, integrates a solution portfolio that automates events as well as performance, which includes change and configuration management. For network teams that need to contain costs while improving network performance and policy compliance, NMC is surprisingly affordable and provides rapid ROI. The HP Network Automation automates the complete operational lifecycle of network devices from provisioning to policy-based change management, as well as compliance and security administration. When combined with NNMI, you get the integration solution that helps you unify network fault as well as availability and performance. This is along with change configuration compliance as well as automated diagnostics. Network automation is one of the components of the Automated Network Management Suite. This also provides a holistic automated approach as well as across the network management domain for including fault as well as availability, change, and configuration. Automation particularly helps environments with large networks as well as complex network devices and a high cost which could be associated with manual integrations among disparate management systems. It provides a graphical integration workspace which lets you easily define complex and manual-intensive workflows. This empowers your network operations centers to achieve great results with easily deployed workflow automation without that need for scripting. The HP Network Management NNMI provides powerful capabilities to enable your network operators and teams to effectively manage a network of any size. This helps you reduce the business risks of downtime as well as being able to increase network service levels. NNMI is one of the solutions that manage the fault availability as well as that performance and advanced network services, which includes your physical as well as those virtualized, hybrid, and those cloud environments as well. The HP NNMI Smart Plugins extends the device and protocol support of NNMI to enable management of a wide range of network devices and services. NNMI is one of those components of the Automated Network Management Suite, which provides that holistic automated approach across the network management domain, which includes that fault as well as that availability, performance, and change. The NNMI Auto Network Discovery, this enables you to extend its capabilities by gathering hints, which leads to identifying additional devices and adds them to the inventory for further review. Furthermore, in NNMI, you have the ability to create those Autodiscovery rules, which can use to filter the device discovery as well as the tenants that can help eliminate discovering devices. As an example would be those workstations or printers. NMI Event Management provides a centralized location for incident views, events, and SNMP traps. You can control the events which are considered business critical enough to show up as incidents in NMI. This also gives you that flexibility to configure how incidences are displayed. With NMI Event Management, you and your team can easily monitor and take appropriate action to validate and preserve the health of your network. The HP iSpy for Performance and other smart plugins for the HP Network Management add powerful reporting capabilities. They enhance NMI and be able to add awareness of specialized network environments, which gives you the opportunity to provide your team with information it needs to anticipate issues more quickly and be able to fix those problems. The NMI iSpy includes iSpy for Performance, Traffic, Quality Assurance, Engineering Toolset, as well as the MPLS, Telephony, and IP Multicast. NMI iSpy Performance for Metrics provides a performance reporting foundation, the Network Performance Server, or NPS for short. And NMI is used for that polling engine for that both full fault and performance capabilities. NMI iSpy Performance metric provides performance data, and this is up for 13 months worth of data retention within the reporting tool for both predefined and custom reports. Some of those main capabilities that we have for iSpy Performance include historical graphs for performance data, performance metrics and baseline thresholding, performance baseline reports, and performance forecast reports. The NMI iSpy Performance Metrics products contains the component which was mentioned is called the Network Performance Server. This component is used by other iSpys as well. The MPS provides both out-of-the-box and is highly customizable reporting across any iSpy domain. iSpy Performance for Metrics is particularly focused on fundamental network interfaces such as SNMP as well as MIB2. It continuously collects as well as stores and manages performance-related metrics from across your network, as well as includes multiple pre-built reports for exploring that data. A highly scalable architecture of the NPS. That foundation itself can handle up to over 500,000 performance polled interfaces on a single server, storing the data in the most granular level. Finally, the tight integration between NMI Operational Console and reporting interface provides operators with seamless transitions from fault data to performance report and back. The NPS reporting allows you to easily and intuitively adjust the granularity, as well as that time range, topology filtering, and display of metric reports for the iSpy Performance for Metrics, or any other reports for that matter. You will also be able to carry these selections from report to report when appropriate across reporting domains. You can choose to filter reports to only to show activity during those normal business hours, or as well as be able to create group data by importing node groups. So this concludes the Network Management Center presentation. And now at this time, I'd like to pass it over to you, Sandeep, who will take us through the Network Management Center demo.
So let's get into the demo, and what you see on my screen is a very high-level topology map for Network Node Manager. So this is very critical for someone who is a network manager or responsible for the availability and the performance of different sites, different network sites we may have across the world or across countries or different data center locations. So what we see at a very high level is 3 domains or 3 sites on this map, which provides me the overall availability and content of, and the state of the entire site. So what this is showing me right now is that this particular group or this particular site is actually consists of 6 nodes, and the current state is normal. And if I want to look at what is the historical status of this particular site, it shows it was 99.8% available through a particular time range, which is by default the number of days that you have been monitoring the device. This is a very high-level topology map, but you can also create your own topology maps based on your role in the organization. So, for example, if I'm only responsible for Australia region, for Australia data center, I can build out a topology for Australia, which includes all the nodes that are part of that particular region or data center and are connected to each other. So one of the other things that I would like to mention in this topology map is not only it is categorized based on the region, but it actually shows that how a particular node, in this case, we'll take this example for this node, which is sitting out there in the Perth location, is actually connected to the other nodes, or basically the relationships that it shares between the other nodes that are in the same region. So what we see over here in the lines is actually a layer 2 or a layer 3 connection, which is going to different interfaces of these nodes. And if I click on this device, like I have clicked right now, and I can expand this window a little bit up, it shows the overall status of my node, which it currently shows the normal, and it shows the management address right here, which is actually used to discover the device. On the right-hand side on the pane, it provides you a little bit of more detail about a very high-level details of what that node is all about. It provides the system contact. So Paris McCoy is actually the network administrator, primary network administrator for this particular node. And what node management mode means managed. It means that this particular node is actually managed by network node manager. And if this status would have been unmanaged, then what network node manager would have done is that it would still have kept it in the topology map because it exists, but it wouldn't have provided the status polling or configuration polling for this particular device. One scenario of doing that is when you don't want your license to be counted against the node, because the way NNMI is licensed is then based on number of nodes that you would be managing through NNMI. The next, it shows the device profile. It shows that it's a Cisco 7200 VXR router, which we are all may be very familiar with. It shows the device category as switch router. So it's basically showing that it has the capability of the layer 2 switching as well as layer 3 routing. And then next, it shows the IP addresses that are associated with that particular device. And then it also shows the interfaces that are captured or being monitored in terms of polling by network node manager, which right now we are polling 11 network interfaces. At a very high level, and this will keep on auto refreshing as you would have seen in the last couple of minutes. It keeps that high level statistics of what is the CPU utilization, what is the power supply status on this particular device in terms of component monitoring, and it shows the last modified date, and also if there are any custom attributes that we have are associated with this particular node. Now, an example of associating a custom attribute, in this case 531, NAID 531, could be because I wanted to group every device which has a custom attribute of 531 to the group called Australia. So I'm using that custom attribute so that I can group. So there could be various reasons that you might want to provide a custom attribute, but this actually, the overall idea of having this central repository of all your network devices and infrastructure elements is actually to manage them at a central location. And then once they have been added and discovered into this central database, where it contains the topology and the performance metrics, you can apply the smart plugins or automation on the top of it. And we'll get into that pretty soon. The next tab I wanted to highlight is the component pages, which really shows the CPU utilization, the processor. This would be more on a troubleshooting side when someone from a NOC team at a level 1 or a level 2 actually troubleshooting what's going on with this particular device. If there is a particular network degradation or a service degradation that is hosted or that touches this particular network layer. The next I want to show is the status history. This is something similar that we saw on the worldwide map, where it shows the status of overall, in percentage, the availability of this particular node over a period of time. And also, one of the interesting facts, you can just click this particular layer 2 map, and it shows you how this particular device is actually related to other layer 2 connections that it has around it. So it shows that Thames, Darwin, Brisbane, those are the topologies, those are the layer 2 topologies that are connected to this particular node. As Mike mentioned earlier, NNMI is multi-tenant, and what it means is that depending upon what my role is in the organization in terms of managing the network devices, an admin can have full access to all the devices or all the sites. But if I'm only responsible for a particular site, we can create a security groups inside Network Node Manager, which I can show you right here, which actually then you can actually apply them roles to these security groups based on what they would see when they log into the NNM. So for example, the Advantage security group over here has access to the nodes in Australia. So that's one of the functionality which is pretty easy to manage inside NNMI. And again, the authentication could be in the NNMI could be integrated with an Active Directory using LDAP protocol, so that the users can log in with their regular Active Directory credentials when they get into the NNMI. The next thing I want to focus on is the discovery. Now, Mike did mention that there are out-of-the-box auto-discovery rules that NNMI can use in order to discover the network devices. So what we are looking right now is the auto-discovery rules inside NNMI. On the left, you have options of auto-discovering the way you want to auto-discover your network devices. So you can do a ping sweep for this particular rule or for any other rule, and then you can select your choice that what shows up after the discovery has happened. What is your rule resolution condition? For example, default, the first choice is short TNS name. The second choice is short sys name, and the third choice is IP address. So what it means is that the device would be, in NNMI, the device would be named by the short DNS if it's able to find it. If not, if short DNS is not configured on the device, it would look for the short sys name to represent that device inside the NNMI. And if sys name is not available, then it would use the IP address, which basically we are using to actually discover the device. Next, we get into the auto-discovery rule, which brings us to this particular window where we can provide the name to the auto-discovery rule and ordering as well. Now, what ordering is really is a ranking. So I can have multiple auto-discovery rules set up inside Network Node Manager. But by putting an ordering number, I can rank which rule I want to run the first. Or I can prioritize my auto-discovery rules in case they are overlapping on different regions to run at a particular time in a particular prioritized order. Next, we can provide an IP range, right? Just mentioned as an example, we can use asterisks. There are different ways you can actually define your IPv4 and IPv6 ranges. So these are some of the examples. You can use a subnet, or you can just use this wildcard mask to actually discover anything that is 10.2.x. So that's one of the ways of defining your auto-discovery rules. The other rule could be for using OIDs, or System Object ID ranges. The difference is, as you would know, is that if I want to discover only, let's say, Cisco devices on my network, I don't want Juniper, HP, or any other vendor to be discovered. So SysOIDs, for the first part of the SysOIDs, would be specific for Cisco. And I can mention those in my ranges so that it only discovers the Cisco's devices. That's one of the uses, one of the scenarios where you use System Object ID. But there could be other reasons why you will use system object IDs versus IP ranges, or you can both. You can use combination of both the IP ranges and system object IDs. The next one of the important things that I want to mention over here on the screen is the discovery by using SNMP. Now, by default, the way NNMI is configured, it is configured to discover network devices, which means your layer 2, layer 3 devices, network switches, or routers. Now, if I want to go beyond network devices and let's say I want to discover network printers, or maybe a virtual environment, VMware ESX host, or a particular Windows server or a Unix machine, then I can select discover any SNMP device over here so that it is allowing the discovery rule to actually discover anything other than the network devices itself. So that's pretty much it. And in describing your or configuring your discovery rules inside NNMI, once that discovery rules has been configured, you would be able to see those rules as on the list when you actually add it. The next thing I want to show is the seeds. So let's say if there is a particular device, and most of the times the best example could be your distribution switch or your core switch, any device in the core layer, where you actually want to start as your topology, discovering topology. That's really the seed. So what you were saying is that, okay, start with this particular device, and then based on the discovered relationships along with that device, the spiral discovery will keep on happening. It will keep on happening till the time you actually go beyond your IP ranges, if you have defined your IP ranges. So an example could be, so let's say I want to add this device with the IP address. I'm using IP address instead of host name. And I want that to be part of my Advantage Inc. So next I do is save and close. So the device is listed right here, and it shows right now that it is in progress. So what it is trying right now is to try whatever SNMP community strings I have configured inside NNMI. It's trying to one by one use all of them to connect to that particular device. There could be a high possibility that SNMP community string has not been defined yet. So in order to keep the track of the status, we can just refresh the page over here, and it will show the status of that particular node. Now next, let's go into the inventory. Now the inventory tab, actually, whatever you were discovering in terms of different configuration items, in this case, nodes, interfaces, IP addresses, NNMI automatically categorizes them into the inventory groups. Now you can create your own customized inventory groups as well based on the attribute selection. But just let's look at the node inventory for now. So at a very high level, it shows all my devices that are part of the discovery, that are part of the NNMI discovery and have been discovered by NNMI down the list, right? And then when I click on any one of them, it's actually going to show the exact same details that we just went over that from one of our groups. So your details of who is the owner for this particular device, what is the status of this particular device. So that's really the container part of the NNMI, where you can always go back and doesn't matter which group or which device, which group the device belongs to. It will always keep this list of inventory of whatever we are discovering. So let's see whether we are able to discover our new device. Okay, so this is really the device that we just added in the seed with the IP address. So right now it's showing no status. And if I go to the node configuration, it's showing me the node configuration, which from the network automation integration, which we'll get into next. So let's get into the network automation, which is really the automation piece inside the NNMI, and look at what we have currently for that particular device. So this is the device description in the network automation. So we see that device origin, which is, I believe, important, which it shows that it is added by NNMI through the user admin, because I'm logged in as the user admin right now. So it shows that the device was added by this particular user via Network Node Manager. Next thing I want to do is that because this switch is pretty new, I just have it on the network. I just pulled it in one of the racks on the network, and that's how it got that IP address. Let's do provisioning for this particular device using network automation. So what I will do is that I would run a command script that I have created as a template for my switches inside a advantaging group. So what it does is that it opens up this UI, which asks me for the task name. I can change the task name. It asks me to select a device or a group of devices that I want to deploy this configuration to. And then it also tells me about the start time. If I want to schedule that at a later time, I can select the time I want to schedule that particular provisioning. And it asks for the task priority, because there could be other tasks that are running at the same time that network automation is executing. So you have to, in order to, if this is something very high priority and you want to run this first before any other task that network automation is running, you can select your priority. But by default, it's 3, and we'll keep it to 3 for now. The next is the command script to run. So basically, this is the different templates that are being created in order to, depending upon what how I want to provision my device. So in this case, I will just select the provision script that I have, or template that I have created to provision the devices under advantaging. So that they are enabled with the SNMP community string. So this is really, it shows, the script really shows that what exactly the commands, and if you're familiar with the Cisco iOS commands, this is really saying that this would be the community string for read-only, and this would be the community string for the read-write on that particular switch. So next what we do is that there are other options that you can do. You can do recurring options. You can run this task at a particular time of every week or every day, but this kind of provisioning is probably going to be one time for me, so I'm not going to select any of that options. So what it's doing is right now is that it's trying to connect to that particular device and configure those SNMP community strings there. So let's go back to the device and let's look at the device task. So right away it shows me that the startup configuration and the running configurations are different. So it automatically, as soon as I ran the task to run the diagnostics or to get the SNMP community string configured, it configured it. Now it's based on what it has analyzed about that particular device. It shows the static and running configurations are different. So that's one of the things that it would automatically discover along with any configuration changes done to the device. So network automation, as Mike defined earlier, is really the configuration management system piece or configuration manager for network devices. And right now we are actually at Hobart device, and what next I would do now, because we have the SNMP community string configured, I'll just do a configuration poll for the device so that we get the latest configuration from that device. So it's completed. So it would show you in detail what exactly was completed or what exactly got failed or maybe was skipped in terms of the configuration poll. And the next I will do is the status poll, so that we know that what is the status of that particular device, whether it's green, red, yellow, based on the out-of-the-box thresholds inside Network Node Manager. So we got all these different metrics coming in as soon as I did status poll on that. So let's refresh it. So you see the signal change from no status to normal status, and now I have these component gauges, which shows me different metrics, depending upon, it's still going to take some time to, another minute or so to get more information on some of the metrics, but I will see it was pretty fast. It provided the metrics right away as long as I ran the status plot on it. One of the other things that is fed by network automation piece or configuration management piece is the changes done to the configuration, and that is really the key part in the network management of any organization. So while I'm troubleshooting, I always want to look at was there any recent changes made to this configuration to this particular switch, and who made those changes. So right over here, what it shows is that there was a configuration change made on this particular switch, right? And we can just click on compare to previous, and it would take us to a network automation window, and it will show the old configuration versus the new configuration. And as you would have realized that this is exactly what we made change a couple of minutes back on the device by running that provisioning task to configure the device with the SNMP read and write community string. So the idea is to capture those changes and capture that who is actually is making changes, because that's really the important piece when it comes to the troubleshooting to have when it boils down to the issues based on configuration changes, unplanned configuration changes made to the network devices. Next, we are going to look at the event management console, or the console which collects all the events that are happening on the network devices. And as Mike mentioned, this is a centralized event management console where all your network devices, maybe they are managed through a third-party device other than an NMI, but the idea is to bring all those SNMP traps or SNMP events back into the central console. So for the operator sitting at a level 1 in the NOC is actually able to look at a consolidated view of everything happening on the network. So the idea is to not jump into 12 different windows and look at the status. The idea is to have one single pane of glass, so I get the overall view of what's happening in terms of events on my network on the network management side. So one of the events that I would like to present over here is this particular event, or the Brisbane switch, which the event says that this is a trap sent out from network automation, or NA, and event is saying the device configuration has changed. And later on, this event is followed by another event on the same switch, which says duplex mismatch is detected between the neighboring ports, which is fast Ethernet 1.0 and this particular host, which is in Perth on 1/1. So what the information we are getting from here is pretty simple. We got two events. One event said the configuration has changed, and the second event saying that there is a topological error, or basically the duplex mismatch between the two interfaces. And this could cause, over a period of time, if there's a heavy load of network, this can cause really the network bandwidth degradation. So in order to further analyze that what exactly is going on, this information is really vital, because you are not only getting the topological information, but it is correlating the topological information with the information it is getting from a configuration manager, which is network automation. So next we look at, okay, what exactly the configuration has been changed on that particular device. And I do the same thing. I go to the network node configuration, previous changes made to the configuration, and it takes me to the network automation window. And over here I can see the duplex full was changed to duplex half by this login. And again, this could be integrated with your TACACS or any other authentication server that you use in order to authenticate the users who are logging into the devices. But it would capture the user, and it would capture the exact change that was made. So that's really powerful So you're not actually looking at only the event, symptom event, which was really the mismatch of the duplex speed between the two interfaces on the neighbor devices, but you are actually looking into the cause as well, that what exactly and how that particular event happened. So that was the part of the event management console, and of course there are different tabs or different columns, and you can customize your dashboards based on you want to have a look at the topology maps in the same window along with the event console. So there are different customization of the dashboard which is available. Right now what I have is the event console on the top and then a detail window depending upon what I'm selecting on the event console above. Next, let's jump into the reporting piece. So when I'm in the nodes, and let's say if I'm on the Brisbane node, I can either right-click from here and go to my reporting menu, which is Smart Plugin for Performance. And as Mike mentioned, that's the Network Performance Server, or what also called as NPS, which is really a business intelligence tool, which is running on the top of a database that is storing all the metrics that have been reported by different components of Network Node Manager. The other way to jump into is I can take an action and I can still go to the same reporting menu. So for the Brisbane, if I click on this, what it will bring up is this component health report, which is really telling me that for the past 1 hour, this is the node, which is the one that I selected earlier, brisbane.packetint.com, and it tells a headline of, what exactly is going on that particular node. So I get the availability and reachability graph, the ICMP response time for that particular, any buffer failures, misses, or memory issues with that particular device. And of course, I can customize this report based on what I want to look at by just running the run prompt, which actually allows me to select a particular device or a particular group that I'm interested in looking at. So right now in the definition of the report, you would see that I've selected this particular device from the node name attribute. So if I want to run a report on a location, I can use select node location. If there is a certain family of Cisco devices or Juniper, I can use the node family attributes. So these are all the attributes that you can actually use in order to configure your reports. Similarly, there are other reports available. Top-end reports is one of the other reports that is pretty much used out there to look at what are the top talking nodes in the environment. And you would see the grouping inside the network or inside this network performance server or NPS is based on what smart plugins you're using. So if I'm using quality assurance, I can run the quality assurance reports. If I'm interested in running iSpy traffic or NetFlow reports, I can run that based on what I'm collecting on the NetFlow. One of the other things that, in terms of scheduling, that I wanted to think is that as far as scheduling, it's really, really flexible. So I can select based on whom I'm sending these reports or scheduling these reports from. I can be at a very granular level. That I can be at a 5-minute level of my performance. I can select the time zone I wish to select for the people who this report, who will be the recipients for these reports. I can select the day of weeks that those reports will be sent at. So there, in terms of time controls, there's plenty of different things, flexibility that you can select in order to when you're scheduling these reports. Next, I would like to get into back into the Network Node Manager, and I would like to quickly go through some of the troubleshooting views that are created out of the box, and again, these could be customized as well. So Path View is one of the tools that is actually used pretty commonly. So let's say if I want to look at right now what is the path actually between these two particular devices, right? So how the traffic is actually flowing, and this is real time. So right now it shows the Thames is connected to Perth, and then the traffic would flow from this particular interface. So I can select either the interface or I can select the entire node as well. So depending upon what my selection is, the details at the bottom would change, right? Similarly, if I go to Darwin, I can select the status of the Darwin. But the overall idea of the path view is to actually look at what is my path view. And if, let's say, if there is this particular node or this particular interface is in red condition, that's probably going to tell me, okay, there is something bad going on. The reason my traffic is not probably flowing with the same speed as I'm expected to Darwin because of the issue at FA1/0, which is really one of the key interfaces in this particular path. Similarly, I can look at the layer 2 neighbor view of a particular device. So I'll just select the same device and look at quickly what is the layer 2 devices that are actually associated with this or related to this particular device in terms of layer 2 topology. And I can further drill down to that particular device and look at different information that I want to look at, for example, interfaces, IP addresses at a very high level. And similarly, there's a layer 3 neighbor view, which is totally based on the layer 3 connections. So quickly, it's going to tell me, okay, these are my layer 3 neighbors for this particular device. And if I select the relationship, it actually tells me what kind of interface is it, if I'm polling that particular interface or not. So that were really the troubleshooting tools which are available out of the box for the operators to quickly determine what's going on in terms of topology. The next I want to look at is the traffic spy, which is traffic smart plugin. So NNMI has this smart plugin which captures the net flow traffic. Right now, what we are looking at is a traffic reporting nodes. So we have 5 nodes that are reporting net flow traffic to the network node manager, and we are at each timer, which is using NetFlow version 9 to report to NNMI smart plugin. So at the very high level, what it shows is that the overall type of traffic, there are top application traffic in, top application traffic out, in terms of what is the application traffic coming in and out of that particular network device. The next, from the traffic reports, I can click on top applications last day or top destinations from this particular node for last 24 hours or top sources. So let's click on top applications last day, and it's going to bring up this window, which really shows the top applications that have been reported by NetFlow to this particular node. Now, based on I can set up the thresholds saying that WOW traffic should not exceed more than 60%. And if that application traffic is exceeding more of 60% of the total bytes coming into that particular device, then send out an event, which would be shown on the event console. So you get to know, so that's really the NetFlow perspective of using the NNMI with smart plugin traffic in order to report that. One of the other key components is if we go back to our main console, is diagnostics. So based on your troubleshooting steps that are most commonly used in terms of troubleshooting the issues, what you can do is that you can create a flow or a workflow of those troubleshooting steps, and you can then further just click on the diagnostics to run those flows in order to capture what exactly is going on with that particular node. So right now, I ran that diagnostics on that particular node, which shows, okay, the NNMI created 4 diagnostics flows from this particular node. So let's look at what those flows are. So if I go into that node and I go into Diagnostics tab here, it says that it has completed show IP route for me, shows spanning tree baselining for that particular node. And if I click on one of these reports, it's going to bring this particular operations orchestration flow, which is going to provide me the router baseline information, which provides the iOS information on that. It got the clock. It ran the clock time for me, management station time for me, and further details like show IP route, show IP protocols, different information that I can configure in a predetermined flow that I want to run right away to find out when I'm troubleshooting the steps. So this information is readily available when I'm actually troubleshooting the stuff. So I just need to click on Diagnostics, and it will run those commands, 4 or 5 different commands, and consolidate the report in a tool for me. And again, that's all is happening from a single management console. Next, I would like to touch on the quality insurance, which is really one of the critical parts these days. Everyone wants to look at how's the QoS or quality of service going on in the network environment. So what it does is really what you have, how it works is you create these probes and you install these probes as they're pretty lightweight softwares and stuff. So you install in these probes in different areas on your network topology. And what they do is that from those areas, it reports back the performance of your quality of service in terms of, it could be a jitter, ICMP echo, or UDP, particular UDP traffic that you want to look at. But the idea is that to provide that particular information in a real time to you, that how that particular class-based QoS or a particular traffic is actually performing at a certain areas in the network topology. So, for example, for this particular probe, I can run a graph which is going to show me the round trip time in milliseconds. And this is, again, one of the views that an SME of the net, who's responsible for quality of service or network manager can run live. And this particular line, which actually shows the round trip time in milliseconds, would change and would keep live and as per the metrics that are reported by that particular probe. Right now, it's doing pretty much stable, but again, the idea is to have this capability of looking at these different quality metrics in the lifetime and track them, what exactly is going on. So, for example, we just saw the line going up to 35 milliseconds from somewhere around less than 30 seconds earlier. So that's the quality assurance part of it at a very high level. Of course, you can always contact Kudos Positive for any further details of any of those smart plugins that we are talking about. So that's that is on the quality insurance side. One of the last things that I want to touch before we wrap up the demonstration is the one of the piece that troubleshooting piece, which could be also very beneficial, is the performance troubleshooting. So if I'm troubleshooting on this particular node and I go to the performance troubleshooting, it's going to bring up this chart for me, and it will list down all the different metrics that I can draw in real time to analyze what's going on with that particular device. So, for example, right now it's showing me this particular utilization graph for memory and CPU utilization in the real time. Similarly, if I expand my device and for example, if I go to this particular interface and I want interface metric to be graphed in real time, I can select interface availability and I can just select the graph that I want to look at. So it shows availability pretty much 100% right now, and all different trace. In this case, it's monitoring the availability max, minimum, and average. All of them are pretty good at 100%. But the idea is to actually look at this real time, and you can turn on the auto refresh so that it refreshes automatically on this particular graph. For example, I turned it on so that I get to see the bandwidth utilization in real time.